Good morning, students. In the previous class, we see some problem involving exercise 1.3. Now we continue the problem. Some concepts were new one to you. I explained the concepts. The next question is, find the domain of 1 divided by 1 minus 2 sin x. Domain means we put in which value of x the given function is possible. The given function has any value. It may be a positive value, negative value, or 0. But the value cannot have a not defined. I give one example of not defined. Suppose I replace this x as a 30 degree. 30 degree whose radian value is pi by 6. What is the value of sin 30? The value is 1 by 2. So 1 divided by 1 minus 2. Suppose I replace the value of x is pi by 6. That value is 1 by 2. So these two terms are cancelled. What is the value of the denominator? 1 minus 1. 1 minus 1 is 0. So 1 by 0. 1 by 0 is not a value, is not defined. So the value of x is pi by 6 is impossible. So now to find all values of x except the value of the denominator is cannot be not is equal to 0. So in this purpose, first of all I will take the value of the denominator is suppose 0. Put 1 minus 2 sin x is equal to 0. What is the reason to put exactly is equal to 0? The value of the denominator is 0, then the given function is not defined. So domain means the function is occur in which value. So suppose 1 minus 2 sin x is equal to 0. Then we find one equation, the minus term becomes that side plus 2 sin x. So the multiplication 2 becomes that side division. So 1 by 2 is equal to sin x. That is sin x is equal to half 1 by 2. In our lower class in 10th standard level, in which value of x it has 1 by 2 just 30 degree. But in higher secondary 11 and 12 we find so many values. So general formula is that we already see the formula in trigonometry. So I explain the formula. LHS is a sign. RHS is some value. In which value of the sine we get 1 by 2 is a 30 degree. So we write it is sine 30 degree equivalent to radian value is pi by 6. We write all the values in radian. So I write here also the radian. So it's not only the value of x is equal to pi by 6 1 by 2. So many values are possible. So I remind the formula. In trigonometry, if sine theta is equal to sine alpha, you remind the formula. If sin theta is equal to sin alpha, the value of theta is equal to n pi plus minus 1 whole power n into alpha. I write the formula. If sin theta is equal to sin alpha, then the value of this theta is equal to n pi plus minus 1 whole power n into alpha, where n is an integer, n belongs to z. So it is a general formula to calculate this theta. Sin theta is equal to sin alpha, cos theta is equal to cos alpha, and tan theta is equal to tan alpha. All the three general formula is there. Here sin is involved, so we write this formula. Now we compare the formula in our given sum. We compare the formula in our given sum. In place of theta here, x. In place of alpha here, pi by 6. Therefore, the value of x, okay, theta place is x. So x is equal to n pi plus minus 1 whole power n. In place of alpha here, what is the angle is involved? Is pi by 6. Where n is an integer. Suppose we replace the value of x, it has infinite number of values, where n is an integer. Suppose I replace the value of n is 0. The value of x is 0 to pi is 0. Minus 1 whole power 0, 1, pi by 6. We substitute that value, the denominator becomes 0. I replace the value of n is 1. So 1 into pi is pi. Minus 1 whole power 1 is minus 1. So pi minus pi by 6. Then to simplify, then the value of x is also we substitute, the value of the denominator is 0. So we put these values of x, the entire denominator value becomes 0. But our motive is the denominator is a non-zero. Because 1 by 0 is not a value. Therefore, now we come to the conclusion that domain is, I write capital letter R, where capital letter R indicates the set of all real numbers except, the minus symbol is called except, we write all the values n pi plus minus 1 whole power n into pi by 6, where n is an integer. So it is a domain of our given set. So what is the conclusion? What is the meaning of that one, sir? We replace any value of this one except R, so the denominator is a non-zero. We substitute this value, the denominator becomes 0. But our motive is the denominator is a non-zero. So except this value we put any real number, then the denominator is possible, so it is called the domain. Domain means the given function has some values. It may be a positive value or negative value, or 0 is also possible. But the value is not contained in, not defined. Therefore, the domain is the entire interval. Or means set of all real numbers except these values. What is the reason to write except these values? Suppose this value we substitute, the denominator becomes 0. So the domain of the given function is capital R except these values. So it is a domain of the given problem. Now we move the next one. Seventh question. You see the question, find the largest possible domain of the function f of x is equal to square root of 4 minus x square divided by square root of x square minus 9. We put in which value of x the given function is possible. Domain means it has some positive value. Okay, what is our given question? For understanding, I write again the given question. F of x is equal to square root of 4 minus x square divided by square root of x square minus 9. You see the values lies within the square root. Within the square root. What is the value of within a square root some negative number? In a square root some negative number is involved, we say it is not real or imaginary. Suppose I put the numerator, the value of x is suppose 3. The value of x is 3. What is the value of the numerator? 4 minus 3 square is 9. 4 minus 9 is minus 5. So this is called the imaginary. And also, in denominator, suppose I replace the value of x is 1. Square root of 1 minus 9 is root minus 8. Is also imaginary. So, in which value of x the given function has imaginary. Now we check. Now I write when x is greater than 0 in numerator. X is greater than 0. Greater than 0 means the 2 greater than number is 3. I replace the value of x is 3. The value of the numerator is imaginary. And the value of x is less than minus 2. What is meant by less than minus 2, sir? We tell one number minus 2 less than number. Less than minus number. X is less than minus 2. Suppose we substitute minus 3, minus 4, minus 5 like this. All this value, square root of 4 minus x square is imaginary. We substitute any value. Now I say x is greater than 2. We substitute the value, it may be 3, 4, 5 like this. We substitute the numerator, that value is imaginary. In the same manner, the value of x is less than minus 2. Less than minus 2, then also the given one is imaginary. Also, when x is greater than minus 3, I come in denominator. When x is greater than minus 3 and x is less than 3. X is less than 3. Less than 3 means 2, 1 or 0. The denominator x square minus 9 is imaginary. So that means there is no real values of x. The given function is not a real value. Imaginary value we can't draw the function. Domain means we draw one function. We know very well in a graph, x-axis, y-axis, all are the real number. But we see here when x is greater than 0 and x is less than minus 2, the numerator is imaginary. When x is greater than minus 3 and the value of x is less than 3, the denominator is also imaginary. So one function will have a imaginary, we can't draw a function. That means it has no domain of the given real values. Therefore, our given question, the largest possible domain is impossible or not possible. We write in two words, this is important. The largest possible domain is impossible for all real values of x. So these lines are important. Our question is find the largest possible domain for the real valued function. So in this function, the domain is impossible for all real values of x. So when it is possible? It's possible when the values of x is imaginary. But in imaginary, we can't draw a plane or a diagram. But it is possible in a Cartesian form is impossible. But it is possible in the organ plane. It is in complex number. It lies in 12th standard level. But here, the largest possible domain is impossible for all real values of x. Now the 8th question. Find the range of the function 1 divided by 2 cos x minus 1. Range is not a domain, it's a range. Range means the given function is possible in which interval. So to find the interval, our question is find the range is not a domain. Domain means the curve is in which place is possible. Range means the given function is a when occur. So to find the range. So we see the denominator 1 divided by 2 cos x minus 1. What is the function is involved? Cos x. So that's why I write, we know that minus 1 less than or is equal to cos x less than or is equal to 1. First, I write one concept. We know that what is the meaning of that line, sir? The minimum and the maximum value of cos is minus 1 and plus 1. The function cos x is the whose minimum value is always minus 1 and the maximum value is always plus 1. So cos x is lies between in this two interval only. Cos 0, 1. It is the maximum value of the function. Cos pi, minus 1. It is the minimum value of the function. What is the reason to take cos here? In our given function, the term cos x is involved. So that's why we will take this cos. Next, we see the sum. This cos x is multiple with 2. So the next step is multiply 2 on all sides. So minus 1 into 2, minus 2. Less than or is equal to 2 cos x. Less than or is equal to 2. So no need to write multiply 2. Just we see the multiply symbol. Multiply 2 on all sides. So minus 2 less than or equal to 2 cos x less than or is equal to 2. What is the reason exactly we multiply 2? This cos x is multiple with 2. So that's why I multiply 2 on all sides. Next we see again the question. This 2 cos x is separated by 1. So the next step, separate 1 on all sides. So minus 2, minus 1. Less than or is equal to 2 cos x minus 1. Less than or is equal to 2 minus 1. We separated minus 1 in all the three cases. Minus 2 minus 1 less than or is equal to 2 cos x minus 1. Less than or is equal to 2 minus 1. Minus 2 minus 1 minus 3 less than or is equal to 2 cos x minus 1 less than or is equal to 2 minus 1 is 1. Okay. It is our given sum? No, it is not our given sum because that term lies in denominator. But here the term lies in the numerator. So the next step is taking a reciprocal. So taking a reciprocal. The reciprocal of minus 3 is minus 1 by 3. The reciprocal of 2 cos x minus 1 is 1 divided by 2 cos x minus 1. And the reciprocal of 1 I say is 1. The reciprocal of 1 is 1. Then what is the changes of this symbol? We do as it is the symbol? No, we interchange the symbol also. If it is a less than, we put a greater than. If it is a greater than, we put less than. I'll give an example. The symbol is here less than or is equal. So I write it is greater than or is equal to greater than or is equal to. So it is not an equation, it is an inequality. So in an inequality, suppose we are taking a reciprocal, the sign should be changed. I give one example. Suppose, you know very well, 2 is always less than 5. Now I will be taking a reciprocal on both sides. So reciprocal. 2 become 1 by 2. 5 become 1 by 5. In this 2, which is big, is exactly of 0.5. Is 0.2. 1 by 5, 0.2, which is big. This one is big. So in an inequality, we changing the reciprocal, the symbol should be changed. If it is a less than, it become greater than. If it is a greater than, it become less than. So what is the reason to take reciprocal? Because it is our given sum, 1 divided by 2 cos x minus 1. So now that's why we are taking the reciprocal. Now, so 1 divided by 2 cos x minus 1 value is, it may be minus 1 by 3 or greater than. Or 1 by 2 cos x minus 1 value, it may be 1 or more than 1. Then how to write, sir? Therefore, the range is, that value is minus 1 by 3 or was big value. What is the name of the interval? Open. Minus infinity. That value is also greater than or is equal. So this value is also possible. Minus 1 by 3. I use this bracket. We already tell what is meant by a open and closed interval. And how to read, sir? One side is open interval, another side is closed interval. So we say it is a semi-open interval. Starting is open and end is closed. So semi-open interval. And another one value is also possible, so union. And you see 1 divided by 2 cos x minus 1 value, it may be 1 or greater than. So 1 is also possible, 1. What is the largest value? It goes up to infinity. Therefore, the range of the given function is semi-open interval minus infinity comma minus 1 by 3 or is nothing but union. How to read? It is semi-open interval, it is semi-closed interval. Starting is a closed interval, so semi-closed interval. So that means the given range, that is the diagram is goes from minus infinity up to minus 1 by 3 or plus 1 to plus infinity. So it is a range of our given sum. Range means what is the possible of this diagram. It is not a domain. Domain means we find the values of x. Range means to find the intervals. So in this interval, our given diagram is possible. So except this interval, our given diagram is impossible. So this is the range of our given sum. How to read this interval? Semi-open interval. It is semi-closed interval. We already tell what is meant by open and closed. Closed interval means in this interval minus 1 by 3 is also possible. Semi-closed means in this interval 1 is also possible. So this is the range of our given sum. Now we move the next one, 9. Show that the relation is given. xy is equal to minus 2 is a function for a suitable domain. Now we create a domain. Then find the domain and range of the function. Given the function is xy is equal to minus 2. Now I say it is y is equal to minus 2 by x. The multiplication x becomes, that's a division. I say it is f of x is a minus 2 by x. We put in which value of x the given function is possible. All values of x, the given function of x is f of x is possible except the value of x is 0. We replace x value is 0, minus 2 by 0 is not defined. Also, xy is equal to minus 2. Suppose I keep x here, minus 2 by y. The multiplication y becomes a division. RHS is a function of y. Let f of y is equal to minus 2 by y. So in both the cases, either x is lies in denominator or y is lies in denominator. Our question is to find, show that the relation is a suitable domain. Now we create a function. Therefore, the required function is you put the name of the function is your choice. It may be f of x, g of x like this. The required function is I will take g of x. Okay? And in both the cases, either x is lies in denominator or y is lies in denominator. R is except 0 to R is except 0. Now we create a function. The function name is g of x, whose domain is R except 0 and codomain is also R except 0. We consider in these two cases, either it is a domain or it is codomain, or in reverse, it is a domain or it is codomain. So our question is show that the relation is a function for a suitable domain. Now the suitable domain is R except 0, whose suitable codomain is also R except 0. Now I say this is the required function for our given relation xy is equal to minus 2. Now we move the next question. In the next question we see some composition of function is involved. It's an easy one, so I don't tell the definition. I explain what is meant by composition of function. Our two functions is there, f and g. Now we combine these two functions. It's not a multiplication of these two functions. We combine the two functions. So we say it is f dot g or f of g. We read anywhere. Is now f is one function and g is another function. We mingle this. We say it is f dot g. So how do you define or how to find f dot g? So f dot g is also we write f dot g of x. Suppose a given function lies with the variable x. We say f dot g is also f dot g of x. Suppose f and g is a function of y. We say f dot g of y. So f dot g is nothing but f dot g of x. Suppose g dot f we write here. How do we write g dot f? We write g dot f of x. So is the first condition. And next one, how to simplify sir? How to simplify that value? What is the first function here? F of. Within a bracket, we remove the symbol g of x. So f of g of x. F of, suppose g of x value is 2. We write f of 2. F of x is defined just x, then f of 2 value is 2. It's an easy one. For I give one example. G of x is 2x. So what is the nature of the function g? The bracket on variable is multiple with 2. And f of x is defined as x plus 1. So what is the nature of this function f? The bracket on variable is added by 1. So g of x is defined as 2x and f of x is defined as x plus 1. Then our question is to find f dot g dot f suppose. To find g dot f. So we write g dot f as g dot f of x. Next one, g of f of x. So g of, we write f of x. First we find the value of f of x. What is the value of f of x is given? Is x plus 1. So g of x plus 1. But how to define g of x? What is the nature of this g? The bracket on variable is a multiple with 2. So here what is the bracket one value? Is x plus 1. So what is the value of g of x plus 1? That value is a multiple with 2. So 2 of x plus 1. So it is a value of a g dot f. We see in the 10th standard level also this sum. Just I recall how to find g dot f and f dot g. So the next problem involving these dot product. So that's why I explained f dot g. So now we see the 11th one. If f, g and h are real valued functions defined on R means real numbers, then prove that f plus g dot h is equal to f dot h plus g dot h. So to prove that one. And also, what can you say about f dot g plus h and justify your answer? So to prove that one, in reverse f plus g dot h we write it is f dot g plus h, and justify your answer. What is the value of that one? First of all, to prove the first one, now to prove f plus g dot h is equal to f dot h plus g dot h. Whenever we prove one result or an identity, we will take first of all the LHS. Suppose we simplify this one, we get the RHS also, then we come to the conclusion the given one is approved. So here also I will be taking the value of LHS. Left hand side. What is the left hand side value? F plus g dot x. We already tell dot neighbor h. We see all are given. We will take it is a real value function on R. So the variable it may be x, y like this. But generally we will take it is a variable is x. So I write f plus g dot h as f plus g dot h of x. F plus g dot h of x. F plus g dot h of x. Next, f plus g, I remove this dot within a bracket h of x. How to define f dot g? F of g of x is the formula. So using this formula, I write f plus g dot of h of x as f plus g of h of x. Next, this h of x is common in both the terms. So now I multiply inside. So it becomes f of h of x plus g of h of x. Next, I write this one as f dot h of x also. Okay, I remove this bracket using the dot product. F dot h of x plus, how to write this one? What is the function occur first? G dot. We remove the bracket symbol h of x. So we say it is f dot h of x is also just h plus g dot h of x is also just h. Now we see is exact the RHS. F dot h plus g dot h. F dot h plus g dot h. So it is the RHS. Therefore, LHS is equal to RHS f plus g dot h is equal to f dot h plus g dot h is approved. So the first one is over. Now we come the second one. One more also we gave. Now to find what is the value of f dot g plus h. Also to find the value of f dot g plus h. So f dot g plus h, we write it is f dot g plus h of x also. I consider the given functions f, g, h along in the variable x. So I write g plus h as g plus h of x. Next, f dot. This x is common in both the functions. So I write it is g of x plus h of x. Next, I remove the dot symbol, f of g of x, okay, f of g of x plus f of h of x. Two step I do. I multiply this f dot inside and also I remove the dot symbol. We write it is f dot g of x as f of g of x plus f dot h of x as f of h of x. Next I write this is f dot g of x plus f dot h of x. Dot symbol is just is a variable x, so we remove f dot g plus f dot h. So the value of f dot g plus h. So the value of f dot g plus h is equal to f dot g plus f dot h. So what is our conclusion? Our conclusion is satisfies associative property. So now I knew one concept, that is the composition of two functions. Actually we read it is composition of two functions, but it is a composition of three functions. Just how to find f dot g? The value of f dot g is nothing but f dot g of x. Next we say it is f of g of x. Then we find the suitable values of x, and the given both the functions f and g, we find the value. So f dot g plus h, or use reverse, f plus h dot h. Just we multiply the composition of these functions. So this is the working rule to find the composition of any functions. The same model sum lies in example we must try.